Welcome to part 3 of the 5.4 notes. So again, guys, what I would recommend you do is pause the video, give the example a try, and then see how it went. So in this problem, we're given that there's a strictly increasing function, has values shown below. We want to use the midpoint rule of Riemann sums with 3 subintervals to approximate the integral from 1 to 10 of f of x dx. Now, in this problem, we're given a table. So again, what we want to look for whenever we're trying to evaluate a Riemann sum is identify the width of the intervals. So in this case, our table goes from x values 1 to 10, which matches our integral. We want 3 subintervals. If you look, there's definitely more than 3 subintervals given. So for us, we want to break this down into 3 subintervals. So our first subinterval can go from 1 to 4. Our next subinterval could be from 4 to 7. And our last subinterval is from 7 to 10. We want to identify the width of those subintervals. So from 1 to 4, that has a width of 3. From 4 to 7, that has a width of 3. And from 7 to 10, that has a width of 3. So we have a uniform width. So in this case, the width of the subintervals is 3. Now, we want to do a midpoint Riemann sum, which means that we want to use the midpoint of our subintervals for the height of our function. So what that's going to end up looking like in this case is the area is going to be the width, which is 3 times. Now, our first subinterval from 1 to 4, okay, that has a total width of 3. Half of that is 1.5. So if we go and add 1.5 to 1, we get 2.5. So we're going to use that value as our height for the first rectangle. So this is f of 2.5. Our next subinterval is from 4 to 7. The midpoint is 5.5. So we're going to use f of 5.5. And our final interval is from 7 to 10. The midpoint is 8.5. So we're going to use f of 8.5. And that right there would essentially be our formula for the area. And if we just go ahead and plug in the given values, so f of 2.5 is 6, f of 5.5 is 11, and f of 8.5, which I did not put my little asterisk, is 16. Again, we're just going to simplify that down. So 6 plus 11, that's 17. 17 plus 16 is 33. And 3 times 33 is 99. So the Riemann sum gives us an area of approximately 99 units squared. So again, guys, we want to be paying attention to, what are the limits of integration, and then how many subintervals are we using, because that does become important. If it doesn't specify how many subintervals, many times it will say use the subintervals identified in the table. So if that was the case, we would do 1 to 2.5, 2.5 to 4, and so forth. All right, we're going to move on to example 6. Again, I would encourage you to pause the video and give the problem a try on your own before we do it together. All right, this time we are going to look at a strictly increasing function. It says has values shown below. We want to use a trapezoidal rule of Riemann sums with 3 subintervals to approximate the integral from 1 to 10 of f of x. Again, we want to break this down as 3 subintervals. So our first subinterval is going to go from 1 to 4. Our next subinterval is from 4 to 7. And our third is from 7 to 10. All right, you might recognize this is just the same table as above. So we have a width of the first interval of 3, second 3, and third is 3. So we do have a uniform width. So in this case, the width of our subintervals is 3. Now, again, trapezoidal rule. This is a formula you guys need to know. Area of a trapezoid is 1/2 the height times the sum of the bases. So base 1 plus base 2. And as we apply that to the Riemann sum, we are going to get area is equal to 1/2. Our width is uniform, so 3 times. Now, got to go back and remember, each of these trapezoids has 2 bases. All right, our first trapezoid is on the interval from 1 to 3. So we're going to use f of 1 plus, we're going to use f of 4. But then we're going to end up having to use f of 4 for the second trapezoid as well. So we're going to use that twice. So we can simply do 2 times f of 4 plus. The second base of that trapezoid is f of 7. Well, again, that's going to be used for the third trapezoid as well. So we're going to do 2 times f of 7. And the final base of the third trapezoid is f of 10. So as we go ahead and plug in the values for those heights, we are going to get, let me just use a bracket, f of 1 is 2 plus 2 times f of 4 is 7 plus 2 times f of 7 is 15 and f of 10 is 19. So again, if you want to just kind of see where all of these numbers are coming from, this 2 is coming from right here. This 7 is coming from right here. This 15 is coming from here. And this 19 is coming from here. So we need to make sure we understand where those values all come from. And as I start to simplify, 1/2 times 3 is 3/2. All right, and then we've got 2 plus 14 plus 30 plus 19. Just simplify that down. We've got 16, 46, and then 46 plus 19, what is that, 65? So let's see, 65 times 3, is that 195? So we have 195 over 2, which would be a perfectly acceptable answer. If you did divide by 2, obviously you could write that as 97.5. Not necessary to do that, but again, you might put your answer that way. All right, guys, that does it for the 5.4 part 3 video and also ends the 5.4 note. So hope you guys got something out of it. Watch the video again if you need to.